Okay, in this lecture, we're just going to skim over the surface of network security. Network security is actually a very complicated activity, but we'll just hit some of the high spots. So the first thing is that there are firewalls within the network, and the purpose of a firewall is to restrict address. So a message comes in with an IP address and a port number, and the firewalls are configured. So you can specify rules that allow messages based on IP address or disallows messages based on IP address, and it will route allowed messages based on port number. For example, messages specifying port 80 will be sent to a special HTTP server. Messages specifying port 443 will be sent to a special HTTPS server. Uh, Firewalls can also be used to detect problems. So one type of attack is a port scan, where the intruder will look for open ports, and so it'll just keep sending messages to the same IP address with different port numbers. And the firewall will recognize this and put the IP address on a blacklist, saying we don't want any more messages from this IP. Firewalls can also be set to act as throttles and limit traffic. And so this is one of the techniques used in terms of, to protect against a denial of service attack. In most networks are complicated, and there'll be multiple firewalls. So here's just a picture of a network. I mean, you don't need to understand this, but the dashed red lines here represent different firewalls for different purposes. So typically, for example, there's something called the demilitarized zone, where outer-facing websites, outer-facing sites that send out web pages are placed, and then there's a second firewall and the intranet, where internal type of activity takes place. Networks have subnets, so when you set up your EC2 assignment, one of the things that's implicit in if you use the wizard, you didn't have to worry about it, but one of the things that's implicit in setting up an EC2 instance is you're on a subnet. And a subnet is essentially a logical portion of a network that looks like a total network. So it's used to divide the network into groups, and each group can have its own access rules, can be protected by a firewall, and so on. So each group looks like a network. There are a whole bunch of security protocols, and they're designed to provide various types of security. Kerberos is one of the older ones, so that you get a ticket or a token, and you use that token, you pass that token around. One of the readings in the assignment is talks about the transport layer security and the SSL. These are protocols that themselves are secure but are prone to implementation errors. One of the things that happens at the operations level is that you look for intruders, and you don't physically look for intruders, but there's a suite of software called intrusion detectors that look for unauthorized users. And the way they work is there's a baseline of sort of normal message traffic within your organization, and the assumption is that intruders will introduce abnormalities, and so the intruder will detect an anomaly. This turns out to be a really hard problem, just because the normal message traffic is very noisy. And machine learning is a typical technique that's used in intrusion detection. So if you want to, for protection, there are firewalls, there are security protocols, there are subnets. These are all basic protection controls. Intrusion detection is a type of detection control. You log traffic. Okay, in order to do recovery and forensics. And that gives you a trade-off between the completeness of the log and the performance overhead of logging. This is always the case with logging. So to summarize, networks are protected partially by firewalls and partially by the use of various security protocols. Networks can be subdivided so that computers on one subnetwork do not have free access to computers on other subnetworks. And the firewalls look for port scans. Intrusion detection looks for anomalies